Hi, my name is Tarun. Hope everyone is doing well here today. In this video, let's learn about the basic concepts of data mining and data warehousing. Let's dig into it. Introduction to data mining and data warehousing. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. Subject-oriented. A data warehouse can be used to analyze a particular subject area. For example, sales can be a particular subject. Integrated. A data warehouse integrates data from multiple data sources. For example, source A and source B may have different ways of identifying a product, but in a data warehouse, there will be only a single way of identifying a product. Time variant. Historical data is kept in a data warehouse. For example, one can retrieve data from 3 months, 6 months, 12 months, or even older data from a data warehouse. This contrasts with the transaction system where often only the most recent data is kept, non-volatile. Once data is in the data warehouse, it will not change. So historical data in a data warehouse should never be altered. Next, let's see three-tier data warehouse architecture. So this diagram gives you a basic idea of three-tier data warehouse architecture. Then it has three tiers. One is tier 1, tier 2 and tier 3. Let's dig into it. Tier 1. The bottom tier is a warehouse database server that is almost always a relational database system. Backend tools and utilities are used to feed data into the bottom tier from operational databases or other external sources. These tools and utilities These tools and utilities perform data extraction, cleaning and transformation, as well as load and refresh functions to update the data warehouse. The data are extracted using application program interfaces known as gateways. A gateway is supported by the underlying database management system and allows client programs to generate SQL code to be executed at a server. Examples of gateways include ODBC, which is Open Database Connection, and OLEDB, which is Open Linking and Embedding for Databases by Microsoft, and JDBC, which is Java Database Connection. This tier also contains a metadata repository which stores information about the data warehouse and its contents. Next, the tier 2. The middle tier is an OLAP server that is typically implemented using either a relational OLAP model or a multi-dimensional OLAP. OLAP model is an extended relational database management system that maps operations on multidimensional data to standard relational operations. A multidimensional OLAP model that is a special purpose server that directly implements multidimensional data and operations. Next, the tier 3. The top tier is a front-end client layer which contains query and reporting tools, analysis tools, and data mining tools. Tier 3. The top tier is a front-end client tier which contains query and reporting tools, analysis tools, and data mining tools. Next, the multidimensional model. This is a basic diagram for a model. Next, the multidimensional model, and this is a basic. Next, you're looking at the multidimensional model, and this is the diagram for that. Now, the working of the multidimensional data model. On the basis of the pre-decided steps, the multidimensional data model works. The following steps should be followed by every project for building a multidimensional data model. Stage 1. Assembling data from the client. In the first stage, a multidimensional data model collects correct data from the client. Mostly, the software professionals provide simplicity to the clients. Mostly, the software professionals provide simplicity to the client about the range of data which can be gained with the selected technology and collect the complete data in detail. Stage 2. Grouping different segments of the data. Stage 2. Grouping different segments of the system. In the second stage, the multidimensional data model recognizes and classifies all the data to the respective section they belong to and also builds it problem free to apply step by step. Stage 3. Noticing the different proportions. In third stage, it is the basis on which the design of the system is based. In this stage, the main factors are recognized according to the user's point of view. These factors are also known as dimensions. In stage 4, preparing the actual time factors and their respective qualities. In the fourth stage, the factors which are recognized in the previous step are used further for identifying the related qualities. These qualities are also known as attributes in the database. Stage 5, finding the actuality of factory. Stage 5, finding the actuality of factors which are listed previously and their qualities. In the fifth stage, the multidimensional data model separates and differentiates the actuality from the factors which are collected by it. These actually play a significant role in the arrangement of multidimensional data model. Stage 6, building the schema to place the data with respect to the information collected from the steps above. In the sixth stage, on the basis of data which was collected previously, a schema is built. Now, let us look at some of the differences between the OLAP and the OLTP. Characteristic of OLTP is operational processing, whereas OLAP is information processing. The orientation of OLTP is transaction, and the orientation of OLAP is analysis. So the users at OLTP are clerk, DBA, database professional, whereas the users at OLAP is knowledge workers like manager, executive, analyst. The functions of OLTP is basically the day-to-day operations, whereas the functions at OLAP is the long-term informational requirements and the decisional support. And the database design at OLTP is ER based and application oriented, whereas the database design at OLAP is stars or snowflake or subject oriented. And the data here at OLTP is current and guaranteed up to date, whereas at OLAP is historical accuracy maintained over time. And the summarization is primitive at OLTP and it is summarized at OLAP. And unit of work is short, whereas at unit of work is complex here at OLAP. And the access to the OLTP is read-write and the access at OLAP is mostly read. The focus is OLTP is data in and the focus at OLAP is information out. And the operations at OLTP is index on primary key and the operations of OLAP is lots of scans. And the number of records accessed is tens at a time and the number of records accessed is millions at a time. And the number of users at OLTP is thousands at a time and the number of users at OLAP is 100s at a time. And the database size of OLTP is ranged from 100 MB to GB and the database size of OLAP is ranged from 100 GB to TB. And the priority is the high performance and high availability of OLTP. The priority of OLAP is highly flexible and the end user autonomy. And the metric of OLTP is transaction throughput and the metric of OLAP is query throughput response time.